go ahead and get out your unit title page. And today's lesson is going to be 1.3, Domain and Range. So yesterday y'all did a paper and notes over intervals and inequalities, and that was to help you with today whenever we talk about domain and range. Alright, go ahead and flip to the first page. Alright, so we're starting our notes over domain and range, and there's two different types of functions whenever we're talking about domain and range. The first one is discrete, and the second is continuous. We're only going to be looking at discrete functions today, and then on Monday we will continue these notes and do the continuous function examples. So to start off with, let's go ahead and define what a discrete function is. It is a function with distinct and separate values, which means that it's not connected. The points have to stay as individual points, and you cannot draw a smooth line through them. Some examples of when we might need to do this is whenever your domain has to be whole numbers. So for example, in this graph here, maybe this would be number of people. So my x-axis could represent something like number of people. I would want this to be whole numbers. Okay, we could have 10 people, we could have 20 people, but you wouldn't want to have like 10 and a half or 30 and a quarter. Okay, you can't have fractional values of people. Same thing maybe with like number of TVs. Stuff that has to represent whole number values would be a discrete function. Let's go ahead and list out the domain and range for both of these graphs. Remember that domain is all of the possible x values. So whenever we're listing the domain of any graph, if we're on the x-axis, we're looking from the left to the right, and we're going to start with the least x value and then move to the greatest. So for the domain, we need to do a curly bracket, and I can tell that my first x value starts at 10, and then as I keep increasing along the x-axis, my next one is at 20, and then 30, 40, and it looks like we just keep increasing by 10, 50, 60, 70, 80, 90. So I'm just going to do a comma, dot, 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 all the way to 90, since we're increasing by 10 each time. Now let's switch, and we're going to be moving to the range. So the range is all of the possible y values. Now we're moving on the y-axis, so we're going to be looking from the bottom to the top. The least y value starts at 15. And then if we move up a little bit, I have another one at 25, then 30, 40, there's one way over here at 50. We have two y values at 55, but if you have the same value, you only need to write it once whenever you're writing your domain and range. And then we have one at 60, and finally 70. Alright, now let's go to graph B. So we're going to do the same thing. We need to list out the domain first. So we're looking at the x-axis. So if I'm looking at the x-axis, I'm looking from left to right. My least x value starts here at -3. Then -2, +1, 2, and then 5. Okay, for the range, I want you to try it on your own for a ticket. So you can pause the video here in just a little bit, write your answer, and then we're going to go over it together. And if you get it right, you can get a ticket. So you should have gotten your first or your least y value would be at -5. then 0. We've got two values at positive 1, but we only need to record it once. And then our greatest y value is at positive 4. So you should have gotten -5, 0, 1, and 4. Alright, now you're just going to do an IXL over finding domain and range of discrete functions. Have a great day.